Alright, so in previous videos I covered uh, the biosynthesis of the fat-soluble vitamins, which are vitamins A, D, E, and K. So in this video I'm going to give a short introduction to the water-soluble vitamins as we now turn our attention towards the biosynthesis of the water-soluble vitamins. And so the water-soluble vitamins are essentially just B vitamins and vitamin C. So the B vitamins, they're not really in order on here. So this is B1, this is B2, this is B3. Um, I'm not sure if there is a B4 or not, but this is B5, this is B6. Uh, this here is B12. Biotin, I think, is B7, and folate is B9. And then there is also vitamin C. And those make up the water-soluble vitamins. And as the name says, these are soluble in water, which means you can put them into water and they will dissolve. All right, so the first one we'll talk about, I'll kind of go in order here. Thiamine is vitamin B1, and the molecular structure of it has this pyrimidine moiety and this thiazole moiety, or pyrimidine ring and thiazole ring. And so this is kind of the structure you will often see. And so down here, I just have this image here showing that this H here is acidic. And so it's this H can come off, this hydrogen can come off, it can be deprotonated. And so this area right here is sort of the business end of this molecule, if you will. And we will see in later videos when we start seeing the things that thiamine are used for, how that is actually used. So here I have I have a list of food sources and the RDI or RDAs rather, the DRIs for thiamine. And I got all of these from a single website that just has fact sheets for all the different vitamins and things you can get from your diet. And I have those all linked to in the description down below. So I'm not going to go through each and every one of these things, but just to kind of a few things from the top. So high sources of thiamine uh, are rice, so white rice or long grain rice and enriched rice, breakfast cereals, so fortified meaning that they add extra into it. And so noodles, pork chops, and trout, so fish and pork are good sources. And so down here, the recommended daily allowance. Uh, so it's for different age groups and for males and females. So if you're watching this video, I would assume you are probably in this group up here. And so about 1.0 to 1.2 milligrams per day is the RDA for this. Over here, I have some lists of symptoms of deficiency. So up here it says thiamine deficiency is rare, but it can occur in individuals with excessive alcohol consumption. So alcohol consumption can lead to thiamine deficiency, both because of the alcohol itself and also because alcoholics often don't have a good diet. So as this says here, where meals are often replaced by alcohol. So these are some of the symptoms of it here. So anorexia and muscle cramps and atrophy. It can have have effects on your mood and things like that. Tachycardia, so that's an abnormal heart rhythm, hypotension, low blood pressure, chest pain, so on. So over here are the symptoms of beriberi, uh, which is uh, which is what you get if you have severe thiamine deficiency. So there are two types of beriberi. There's what's called wet beriberi and dry beriberi. So dry uh, is mostly affecting the nervous system, where the wet version is the cardiovascular system. Uh, and so this can lead to, in the dry version, things like difficulty walking, loss of sensation, and pain and tingling and things like that. With the cardiovascular version or the wet version, uh, it can uh, it can affect the heart rate and breathing, and can cause swelling of the lower legs. So, in uh, unless you're a severe alcoholic in our Western sort of developed society, this is fairly rare. All right, so then we move on down to vitamin B2, which is riboflavin. And I just have this flavin mononucleotide here, and uh, getting this, so turning this into this, and then further on to flavin adenine dinucleotide and things like that, which are just adding more things down here. But up here is, once again, sort of the business end. Uh, this These nitrogens here are involved in redox reactions. Uh, so things in metabolism, energy metabolism, use a lot of this kind of stuff. But uh, so, I mean, we've already run into flavin adenine mono or dinucleotide rather in the biosynthesis of uh, some of the uh, some of the fat soluble vitamins. So we've already kind of seen a little bit how this is actually used. But anyway, like I said, this is involved in redox reactions in a lot of enzyme catalysis, including, I guess, sort of most known about the B vitamins, things like sugar and fat metabolism. And so once again over here from that same website I have this list of sources. So up here this has beef liver uh, as as a very high source. Cereals, oats, milk is pretty high. Beef again, and so once again I have the links to in the description if you're interested in looking further into this list of sources. Down here, once again, we have the RDAs, and so for people between the ages of 14 and 51 plus, about 1 to 1.3 milligrams is the RDA. Here I just have copied from Wikipedia some of the functions uh, of the flavin mononucleotide and flavin adenine dinucleotide, which, as I said, are built out of riboflavin. And so flavoproteins are of the electron transport chain. I will get into uh, into painstaking detail of the electron transport chain in later videos. Uh, so I'm not going to go into that here. Required for the production of pyridoxic acid. It's a primary coenzyme form of vitamin B6. So oxidation of pyruvate. Uh, so these ones are kind of the ones we will be running into a lot. Uh, fatty acid CoA dehydrogenase. We've already seen in other videos converting retinol into retinoic acid. Yeah, and so you can, this is involved in, like I said, a lot of redox reactions. Um, then we move on to niacin, which is vitamin B3. And so this can come in two different forms, which is the nicotinamide and nicotinic acid. And so that's just a change here. Um, and I mean, that's a pretty significant change because this is going to be a lot more acidic than this. Um, but these are both sort of niacin. These are both vitamin B3. And I just have this over here because one of the main things for niacin, which you can see is right here on this molecule, is nicotinamide adenine dinucleotide. So nicotinamide has the nicotinamide version of this on it. So this can be converted into this as well. And once again, just like the riboflavin, just like the flavin adenine dinucleotide, this is nicotinamide adenine dinucleotide, and it is also used in redox reactions in the body. Um, I have the sources here again and the RDAs. So the RDAs in the sort of 14 plus years of age uh, are around 14 to 16 milligrams for that. So beef liver and chicken breast and turkey breast and salmon. So a lot of meats are rich in niacin. Over here, I have this list of mild deficiencies in vitamin B3, so coated tongue and sores in the mouth, irritability, nervousness, skin lesions, so on and so forth. Um, but then down here, the more severe, what can become more severe, they call these the 4Ds here. So the 4Ds, which are diarrhea, dermatitis, dementia, and death. So this can be if you have a, a large deficiency in vitamin B3, then you can end up with a lot of these different symptoms, and it can eventually lead to death. So down here is pantothenic acid or vitamin B5. Um, so there are, and I'll go through this later on, there are multiple enzymatic steps that will turn this into this pantoic acid, which is then incorporated into this coenzyme A. So if you have heard anything about metabolism, you may have heard of things like acetyl CoA. Well, this is the CoA molecule, which pantothenic acid is needed for, and so that is a coenzyme in a lot of the metabolic processes, with acetyl CoA being a very large one or a very important one. Acetyl CoA is an intermediate in a lot of pathways, and it's sort of the exchange in a lot of pathways. So, like sugar metabolism goes to acetyl CoA, which also goes to fat metabolism. So that's probably one of the bigger ones. But this also goes into things like the Krebs cycle, and from that there are different amino acids that can be made from it. And so this is sort of a central molecule in a lot of these different metabolic pathways. And so coenzyme A, which we need pantothenic acid or vitamin B5 for, is important in that. Once again, as I said, I have the food sources here, the RDA. So the RDA that we're kind of looking at here, so about 5 milligrams for this. You can get quite a bit of it from beef liver and cereals and shiitake mushrooms, sunflower seeds, chicken, tuna, avocados. So it seems like kind of interestingly enough, a lot of more fatty type foods is where you get this water soluble vitamin. But I mean, these things would also contain water as well. Uh, and yeah, so that is vitamin B5. Down here we have vitamin B6. And vitamin B6, there are actually multiple versions of it. So this one here is sort of the most common one. If you were taking like a vitamin B6 supplement, then you were probably taking this one. But they're all pretty similar. So this is different here. This is an oxidized version of this one, and then this has this primary amine group on there. But otherwise, they're all very similar. These are just the same things, but they are phosphorylated on this oxygen here. Yeah, so down here, once again, just sort of the names of these different vitamin B6. So sources for it are chickpeas, beef liver, tuna, salmon, chicken breast, cereals, potatoes, turkey, banana. So, uh, once again, quite a few animal sources are very high up on the list. Ooh, I don't know why that zoomed out like that. Interesting. Anyway, I think I can still keep going through this. Um, it's kind of hard to read it now. I don't know why my program did this. But anyway, I guess we can just move on because I'm not really going through those lists much anyway. Biotin, vitamin B7. So biotin is one of its more functional things is the fact that it's this kind of long molecule. We will see when we get into metabolism in later videos that having that long chain kind of allows it to move around in different directions quite a bit. And so here we see it's these nitrogens here that are kind of acidic because they are adjacent to this carbon double bond oxygen here. And so one of the main things these are used for is this carboxylation. So adding and taking away CO2 from other molecules. And so we can see here the biotin carboxylase and the carboxyl transferase. So the carboxylase is actually adding the carbon dioxide onto it, and the carboxyl transferase is then transferring that CO2 onto some other molecule. All right, yeah. So anyway, I was talking about biotin, and so the acetyl-CoA carboxylase and the methylcrotenyl-CoA carboxylase. So as I was saying, this adding this carboxyl group onto things is a large function for biotin. So biotin deficiency can lead to things like brittle nails, conjunctivitis, also known as pink eye, depression, dermatitis, fatigue, hair loss, so neurological symptoms, weakness. A lot of a lot of these symptoms seem to be popping up in quite a few of these deficiencies for the B vitamins, which is likely one of the reasons why they are all grouped together as B vitamins. So then the next one here is folate, and so that can also be called vitamin B9. So folate has this 2-amino-4-hydroxy pteridine moiety, and then this p-aminobenzoic acid moiety. And then it can have a varying number of these glutamates bound to it. I believe it always has at least one, but then it can have a varying number of these other glutamates here. So sources for this, once again, beef, liver, spinach, black-eyed peas, cereals, rice, asparagus, Brussels sprouts. So quite a few of the more sort of dark green sort of vegetables are at the top here. And then so for RDA, so maybe about 1400 mcgs or micrograms. So you don't need too terribly high of doses for it compared to some of the other ones that we've looked at. Over here, I just wanted to quickly show that vitamin B, that this folate, this vitamin B9, has quite a few different forms actually. So our dietary form is folate, but then it can be turned into dihydrofolate and then tetrahydrofolate. And so this is sort of the kind that's actually used in the body. And so down here we can see the different forms of it, the N10 formal tetrahydrofolate, the N prime methynyl tetrahydrofolate, and so on. And these are involved in things like tryptophan metabolism and histidine metabolism, serine and glycine. So purine bases and thiamine are constituents of DNA. And then methionine is another amino acid. So it's involved in a lot of in the metabolism of a lot of things. And this is just kind of showing the same thing, but so glycine, and that's using the N5, N10 methylene folate, and so the methionine and homocysteine, which is kind of the big one for folate, is making sure we don't have this high homocysteine, which can be toxic, and that's using the N5 methyl folate, and so generating the thiamine or monophosphate, which is for DNA. So yeah, this just kind of shows the same thing, but in a little bit different of a way as what this was showing. And over here is kind of showing the same thing again, but I liked this one because it actually showed the structure. So if we have this N5 methyl tetrahydrofolate, it actually has a methyl group right here. The N5 N10 methylene then has this this nitrogen here actually bind to it, so we end up with that right there. And then we can have the N5 N10 methynyl tetrahydrofolate. And once again, I'll go through this in a lot more detail in later videos when we actually get to things like this homocysteine cycle, which also uses vitamin B12. And so I'm not going to go through this in great detail here. So then we get to vitamin B12, or Cobalamin, which is this large molecule here, and this can have 4 different forms, where this R group here can be substituted out for these one of these 4 different things. So we can have the hydroxycobalamin and the methylcobalamin and the cyanocobalamin and the adenosylcobalamin. Excuse me. So up here, sources, so things like clams, liver and beef, trout, salmon, trout, tuna fish, so a lot of fish sources. are high in vitamin B12. And so 14 plus years, we need about 2.4 micrograms uh, in order to have our recommended daily allowance. And so over here, once again, so this is actually that sort of a cartoon version of that that methionine and homocysteine that I was talking about before. And so using this S-adenosyl methionine to methylate things, this uh, talks about DNA methylation, but there are other things that can be methylated, generates this S-adenosyl homocysteine after the methyl group is removed from here. Then that is converted into homocysteine. And homocysteine can become toxic if too much is built up. And so vitamin B12 as well as folate are involved in converting homocysteine into methionine, which is just an amino acid, which can be used for things like proteins. But then this shows that can also be used to generate more S-adenosyl methionine. But B12 is also used in the mitochondrion for for fat metabolism. The B12 is used here when we have this methylmalonyl-CoA, which is I believe, a 3-carbon fatty acid, is used to turn it into succinyl-CoA, which can then enter the Krebs cycle or tricarboxylic acid cycle, or whatever you want to call that cycle. And so we need vitamin B12 in particular for this odd chain fatty acid metabolism. And so that's sort of what I have over here, is just showing that again. So we have these odd chain fatty acids that end up as this 3-carbon fatty acid, and this is what vitamin B12 is needed for, is generating this succinyl-CoA. And so symptoms of vitamin B12 deficiency can be things like disturbed vision, changes to mobility, glossitis or mouth ulcers, jaundice, dizziness, mood changes, high temperature, sensations, so like the feeling of your limb being asleep, and fatigue are all symptoms that you can have from vitamin B12 deficiency. So down here we have vitamin C, or ascorbic acid, and this is involved in a lot of redox reactions. So this I have here is the redox of vitamin C. So you can have this L-ascorbic acid and this L-dehydroascorbic acid. So these are in a reduced form, and these are in an oxidized form here. And so that is the redox reaction of vitamin C. Sources over here, so things like red pepper, orange juice, oranges, grapefruit, kiwi fruit, green pepper, broccoli. So those fruits and vegetables are all high in vitamin C. And for our RDA in the sort of 14 plus years of age. And once again, if you're interested in looking into these in more detail, links are in the description down below. So 75 to 90 milligrams, depending on whether you're male or female. So right here I just have a little cartoon here for the ascorbic acid, which is this AA. So that's the reduced version of vitamin C, and the dehydroascorbic acid is this oxidized version. And so we see that that's actually interacting with the tocopherols, which are vitamin E. And so this is passing electrons uh, to our vitamin C, which is then passing those electrons to this molecule here, this glutathione. And then the glutathione is passing it on to NADP. Uh, and so sort of the main thing I wanted to show here is that vitamin E and vitamin C are sort of working in tandem on this. I don't want to go too deep into that right now. As usual, later videos when I get more into metabolism and things like that, I will go into this in much more detail. But here, I also wanted to show that collagen, so vitamin C, is needed for proper collagen production, and it is hydroxylating either proline, so this is proline or lysine, and so it's adding this hydroxyl group onto these, which gives these OH groups, as we can see on these long collagen chains, that allow them to cross-link into this three-stranded collagen, where if we are under-hydroxylated, then that can cause the breakdown of collagen. And so this is done using semi-dehydroascorbic acid and ascorbic acid, using iron as well. So iron 2 plus and iron 3 plus. So this is redox, and that is adding onto proline and lysine these hydroxyl groups here. Then up here is just vitamin C deficiency. So we could see things like easy bruising, nosebleed, digestive disorders, immune impairment, joint pain, dry skin, dry or splitting hair, slow wound healing, and gingivitis. And you can think with things like gingivitis and slow wound healing, sort of the most famous uh, disease that comes from vitamin C deficiency is scurvy, which one of the symptoms, one of the more notable or at least noticeable symptoms are sort of the bleeding gums and things like that. And so not getting enough vitamin C can result in those symptoms. And yeah, I think that is everything I wanted to talk about in this introduction. In the next video, I will get into thiamine biosynthesis, and I will see you then.